Okay, so we're on to question or part G here, and we're given some more data. After the bullet leaves the rifle, it strikes a block of wood which has a mass of 5.1 kilograms and is sitting on a horizontal surface which has a coefficient of sliding friction of mu equals 0.83. I took the liberty of writing down some data beforehand because we have a bit of work and it might take time. So what we're doing in this we're trying to find force, right? So first of all, obviously, we need to say we know the equation for force, which is force equals mass times acceleration. Then we also need, we don't have acceleration, but we have the final velocity and the initial velocity. Forgot to write that in there. So you have final velocity and initial, and you have the time it takes. So we can also say we know the we know we can find the acceleration because we know that acceleration equals the change in velocity over time. And this equation is actually used to find that impulse equals force times time, but that's something completely different. So we have this information. We can just start substituting and finding answers. So let's do that. You have acceleration equals v, and change in velocity is the final velocity minus the initial velocity. So this is just going to be 27.05, and all of that divided by the time. The time being that being 0.38, and you find your answer is, let me check. It's around 71.18 meters per second squared, so that's quite a large acceleration, but you know, that's what we're working with. So that's the acceleration of the rifle. Then we simply use, so this is step 3 continued, we use the equation for force. Since we have the mass and the acceleration, we can easily just use this equation to multiply the two parts together. 2.44 times 71.18. And you get that the force is around, and this is G, so you get that is around 173.69 newtons. Is this reasonable? Yes, I just said yeah, it checks out with the data, so you know, you can say that, or you can say something else, because that's kind of a crappy explanation. So yeah, that is part G. Now we have part H. Oh, this is a pretty complicated one. Oh, this is actually where we use this data. We actually we got, by the way, we got the time from step G itself. There was something that said that the time was 0.38 seconds. So yeah, but I read this before. It says basically the new information is actually for this this part I just started a whole new started the whole thing from scratch from step 1. So let's do that. H. Let's see, where's all our data? I'll just pull it all from my sheet. So I said I used new variables, 0.15, and this was probably unnecessary, but actually I put a lot of work into this specific letter, and I might not have needed to, but I don't know, I found the answer, so that's what matters. Alright, so you have, actually I'm just going to pause this and write the data. Okay, so I wrote in all the data, and here's what we have, all this information. Now what are we going to use to find the, again, we're looking for the velocity of the bullet block combination. So what are we going to use? We're going to use the law of conservation of momentum, right? So the sum of the momentums beforehand, that being the momentum of the bullet and the momentum of the wood, will equal the sum of momentums after. And for after, let's just say P, B, comma, W. This is the, since this is an inelastic collision, the two objects combine, which means they are one entity, I guess you'd say. So we know this is going to be 0 because the velocity of it's not moving, so no velocity, no momentum, no velocity. And we know this is 66 from that. So first, let's combine the masses, and I think it's 5.2 kilograms. 5.25, sorry. I'm not that bad at math. And we have the velocity, which we don't know. Let's say B, comma, W. Okay. Okay, so this equation, this isn't too bad. Then we just divide both sides by 5.25, and we get that the velocity of this system is, let's see, around 12.57 meters per second. And this is actually we're going to use this number quite a bit for the succeeding questions. So what step was it? H, or yeah. So this one wasn't a lot of work, but the next one is, yeah, the next one's a bit. So that's step 4, and is this reasonable? Yes, it is. You have I would say yes, because you have a much larger mass because you're combining the masses, and you have you know the average velocity is going lower because the wood lower than the bullet's velocity, because the wood's velocity is 0. So now let's move on to question, or let's see, I. And question I is quite a bit of work. It's the question is, how far will the block slide along the horizontal surface before it comes to a halt? So we're looking for distance. Now, to convert velocity to distance, we need to use a bunch of stuff. Let me just draw a dividing line. Step J. Step 1. D. I'll probably write it in. Give me 1 second. Okay, so I'm back, and this is all the new data we need because we're using the data from beforehand as well. But the formula. So basically, there's since this whole system, not the system, since the wood and the bullet are going to decelerate to a stop, that means they're going to change their momentum from what it was beforehand. So that's going to be an impulse. So we know J equals, and this is actually interesting. We're going to say J equals Ft. So the force is going to be friction here. But then we're also going to say that this whole thing equals M change in V. The reason for this is because a change in momentum is a change in the whole mass times velocity, and we know that the mass isn't going to change, so we can just say the change in momentum is mass times the change in velocity. So that is and also let's go ahead and write the equation for force of friction here. This is going to be quite a sort of a bit of a mess, but that's what we need to do to find the answer. Then we're also going to say that force normal, let's go ahead and say force normal equals the force of gravity. Technically, it's the force of gravity is negative and the force normal is positive, but I don't care. So yeah, because these two numbers we're going to say are positive. So that's all the equations. Let me make sure here. yeah, that's all the equations we'll be using, at least for now. Before we also have the distance formula, but let's write that later. So let's see. Let's write horizontally. So you have this information. Now let's move on to step 3. And this is doing the work, and there's a lot of work. So you have the combined mass of the system being 5.25, and you have the change in velocity being, the initial velocity is that 12.757 number. So I didn't round, I used the exact number, but yeah, you can use the rounded number. So it's actually negative because the change in velocity is final minus initial. Final is 0, initial is that negative thing. So that all equals force of friction times time. Times time. So now we have two variables here. Let's solve for one. Let's solve for force of friction. Force of friction equals 0.83 times force normal. What is force normal? It is 9.8 times the mass being 5.25. And actually you could plug this in right now, or substitute this in right now and sort of cancel, because you have 5.25 on both sides, but I didn't do that, so you know, we're not doing that. You can, again. And the answer you get for force of friction would be 42.7035. Just gonna make sure. Yes, 42.7035. So now you're gonna say, now we're looking at, actually another thing, time is positive obviously, so we're just gonna say everything in this equation is positive. So I take back this being negative. Or, well, I guess you could also say the force of friction is negative. You could do, that's more right, so let's just do that. Let's say this is negative, because it goes against the whole thing. So then you would have time. So if you plugged in or substituted in force of friction here, you would get that time equals, there's a negative in the numerator and denominator, so let's just not write that because I'm lazy. We're at 5.25 times 12.57 all over, okay, that's close. I said the numbers, so you don't need to judge my handwriting. You know what they are. Oh, all over 42.7035. And that all equals, after doing the math, using my calculator, shout out to Riker there, 1.54 seconds. But we're not done. We can use this number to find the acceleration, and we can use everything we found from that to find the distance. It's very possible that I went overboard and I did too many steps. However, I did it, so we're doing that in this video. And we have 1 minute left, so I probably won't be able to finish unless, you know, I work fast, which that never happens. So we're going back to kinematics here. Velocity final, or final velocity equals initial velocity plus acceleration times time. Now we know the final velocity is 0, so we're just going to say the negative initial velocity, subtract, so say this is 0, subtract the initial velocity from both sides, and you get that the negative initial, you get that. Okay, so then we know the initial velocity was, we can say that's negative 12.57, and let's just solve for acceleration right now. Okay, out of time.